Everybody is talking about the energy transition. What is our contribution for cutting the carbon?
Well, we have spoken already now about industrial heat pumps and the role how it can replace fossil fuels in the industry. But of course, there's much more in our portfolio than just industrial heat pumps. Turbo compressors are like the key to many of the processes that are needed for this energy transition and cutting the carbon. And of course, the most important technology that comes to my mind first is the carbon capture, utilization and storage technology, or short CCUS. That's like the disposal of the CO2 emissions from an industrial process. It's taken from the gas and then put into a safe place, like in depleted gas field, or it can be used to make other chemicals. That's the U in carbon capture, utilization and storage. But a part of that, of course, we have much more technology to offer, such as hydrogen machines that can be used to liquefy hydrogen before it's put into ships and shipped overseas to the destination where it's finally used. And for these machines, we are offering the technology to liquefy, to keep the hydrogen at low temperatures, and later, of course, to bring it back to the right pressure before it's used in power plants.
Rasmus, you mentioned the fridge several times. Is a normal industrial heat pump working in the same way like a fridge?
Well, that's a bit of an obvious answer. Is tricky here because there are different types of heat pumps. But generally speaking, yes, it's comparable to a fridge. You have always a closed loop where compressors working in, where you have heat exchangers, and where you have other similarities like the filling with a gas that can evaporate and condense on other parts. So the basic principle is the same. The fridge, however, is always working as a so-called subcritical heat pump. This means all of the process happens below the critical point of the gas. I don't want to go too deep now into the thermodynamics, but there is something called a critical point. When you're below that point, you're subcritical. Once you're higher than that point, you're in a transcritical process. And this transcritical process offers you some advantages. You can have much more power in a smaller machine. But the turn side is everything runs on very high pressure. So easy answer, yes, it's comparable. Long answer, depends on the process, what you pick.
Okay. So I see we can deliver a significant amount of heat energy to our customers' processes.
Mm-hmm.
In which form do we deliver this energy normally?
Yeah. So that's, again, depending on the industry the heat pump is supposed to go into. If, for instance, we are delivering heat into a city grid like here Cologne, then the heat pump needs to deliver liquid water at a temperature up to 120 something degrees. And this level, of course, can be totally different if you're installing a heat pump in, for instance, a paper factory. In a paper factory, the system maybe needs steam at 6 bar or something like that. So then the same heat pump needs to deliver steam at 6 bar. We can do both, and the cool thing is that if you replace a steam boiler that is normally driven by fossil fuels with a heat pump, you can decarbonize the process because you can make the same steam without burning anything.
Okay, so we as Atlas Copco Gas and Process can have a significant impact on the electrification of the industrial processes?
Yes, of course, because as we just said, the technology we are offering can by 100% replace in most industries the use of natural gas, fossil fuels and similar combustibles. So yes, we have a significant impact, or at least a chance to do that here.